In this video, we are going to study about calculating the energy based on the number of photons of a certain wavelength. Calculate the number of photons in a 2.00 millijoules light pulse at A 1.06 micrometers, B 537 nanometers, C 266 nanometers. We know that energy E equals h nu, where nu is the frequency, which is also equal to hc over lambda, where lambda is the wavelength. H is the Planck's constant and c is the velocity of light. Now, this is valid for one photon of light. For n photons of light, E equals n times h nu, which is n times hc over lambda. This equation is for one photon of light. For n photons, E equals nh nu or nhc over lambda. So coming back to our question, calculate the number of photons in 2.00 millijoules light pulse at 1.06 micrometers wavelength. So E equals nhc over lambda. So n, the number of photons, equals E times lambda over hc, which is 2.00 times 10 to the negative 3 joules, because 1 millijoule is equal to 10 to the negative 3 joules, times 1.06 times 10 to the negative 6 meters, because 1 micrometer is equal to 10 to the negative 6 meters, over 6.626 times 10 to the negative 34 joules second, which is the Planck's constant, times 3 times 10 to the power 8 meters per second. (1.07 times 10 to the 16 photons). Next is part B, 537 nanometers. So again, E equals nhc over lambda. So n equals E times lambda over hc. Energy is 2.00 millijoules. So 2.00 times 10 to the negative 3 joules, because 1 millijoules is 10 to the negative 3 joules, times lambda is 537 nanometers, which is 537 times 10 to the negative 9 meters, because 1 nanometer is 10 to the negative 9 meters, over 6.626 times 10 to the negative 34 joules second, times 3 times 10 to the power 8 meters per second. That gives us 5.41 times 10 to the 15 photons. When lambda equals 266 nanometers, Again, E equals nhc over lambda. So N equals E times lambda over hc, which is equal to 2.00 times 10 to the negative 3 joules times 266 times 10 to the negative 9 meters over 6.626 times 10 to the negative 34 joules second times 3 times 10 to the power 8 meters per second. That gives us 2.68 times 10 to the power 15 photons. The power output of a laser is measured in units of watts, where 1 watt equals 1 joule per second. What is the number of photons emitted per second by a 1.00 milliwatts nitrogen laser? The wavelength emitted by nitrogen laser is 337 nanometers. A 1.00 milliwatts laser delivers 1.00 times 10 to the negative 3 joules in 1 second. This energy is equivalent to what is given out by 1 photon. For n photons, energy is n times hc over lambda. Also, 1 milliwatt equals 1 over 1000 watts. We are already given the conversion that 1 watt is 1 joule per second. So, N equals E times lambda over hc, which is 1.00 times 10 to the negative 3 joules times 337 times 10 to the negative 9 meters, because 1 nanometer equals 10 to the negative 9 meters over 6.626 times 10 to the negative 34 joules second times 3 times 10 to the power 8 meters per second. That will give us 1.70 times 10 to the power 15 photons.